Good morning, all. Let me get my glasses on so I can see what I'm doing. Hope y'all's having a good day. We're not doing too bad here. What I have is a hockey puck SCR. And in order for a hockey puck SCR to conduct, it has to be compressed. And I don't have a heat sink assembly to compress these hockey pucks to test. But what I do have, I got to thinking the other day, well, you know what? We can use a clamp to compress hockey puck SCRs. Now this is a clamp for woodworking. It's insulated on both sides so we won't short the anode to cathode with the clamp. Now I have two metal bars, and in order to clip on the SCR with clippy leads so that we can hook up our test, I have these two metal bars. So we're going to fit the two metal bars and the hockey puck in this clamp and compress the hockey puck. Let's look at the drawings of our test setup, and then I'll clamp the two metal bars and the hockey puck in our clamp assembly. But let's look at our test setup real quick. It's very simple, not too hard to hook up. We're going to use a variac plugged into the wall, 120 volts AC single phase into the variac. The output of the variac is variable with this little knob right here. We need to make a DC voltage for the SCR. We're going to adjust the variac so that out here we'll have about 70 volts DC on the anode of that SCR. So when we increase the voltage here on the line in of the bridge rectifier, the DC voltage on the positive side and the ground side of the bridge rectifier will increase. That DC voltage is filtered by these two parallel 3300 microfarad 400 volt electrolytic capacitors, and that will supply our positive 70 volts DC to the anode. Down here on the cathode side, going to bus ground of the bridge rectifier and filter capacitors, is a 120 volt 100 watt light bulb. That's going to be our load in the cathode. To turn on that SCR, to fire that SCR, I have a variable power supply that will drive into the gate through this 270 ohm 5 watt resistor. And that, when we increase the voltage here, at some point that gate is going to fire that SCR. Now I need to add something, and I'm going to put a forward bias diode right here, and that way when this turns on it won't backfeed into the power supply. A little safety circuit right there. Let me add that in there. Now you can use 1N 1007 diode for that guy right there, for that diode. That way if we have any voltage from anode to cathode feed back this way, it won't hurt your power supply. you don't want to damage your equipment. Okay, let's hook it up and do the test on that SCR. First thing we have to do is get our hockey puck SCR clamped. Let me open up that clamp a little bit. Just a little bit. Let's put our bars right there. We'll get it close to start with. And we can rearrange everything if we need to. Bring our wires up. a little bit, straighten up those metal bars. Okay, let's get everything centered without everybody falling out of the clamp. Okay, that looks pretty good. Yeah, it looks good. Okay, I'm gonna tighten this down. Now let's see what our resistance measures like right there. Set my meter to ohms. Let's get everybody in the picture. Now let's see what we measure like. Anode to cathode with black lead on anode and red lead on cathode, we have 28 mega ohms. Let's reverse our leads. Red lead on anode, black lead on cathode. We got 15.9 mega ohms. That should be good enough right there. Let's hook up for the test. Okay, who's first? Let's take bus plus and connect it to the anode. Now that's what we got these metal bars here for, so we can connect onto that hockey puck SCR. This red lead right here, that is our bus plus from the bridge rectifier. Now, let's connect the cathode of the SCR to one side of the light bulb bank. Here's the cathode. Here's one side of the light bulb. Okay, so we have this part connected, bus plus to anode, cathode to one side of the light bulb. Now we're going to connect the other side of the light bulb to bus ground of the bridge rectifier. And I'm going to do that with a wire nut. This brown wire right here is bus ground. So we're going to use a wire nut, connect the other side of the light bulb to bus ground of the bridge rectifier and filter capacitor. Okay, so that takes care of the power to the SCR and light bulb. Let's connect the gate. Let me move this out of the way. We want to take our variable power supply and connect that to bus ground. So ground of your variable DC power supply to bus ground of the bridge rectifier. You want to take the positive side of this power supply and connect it to the anode of our diode. This 1N7000, 1N1007. Alright, the cathode of that diode is going to go to the 270 ohm 5 watt resistor. Let's get everybody in the picture here. And the other side of the resistor is going to go to the white wire of the SCR. The white wire is the gate. Alright. Now we want to bring that variac up so that we have 170 volts DC. Alright, there is, come down a little bit. It should do it right there, I think. That should do it. We got 72.4 volts DC across that bus capacitor. And if we were to measure across the hockey puck SCR, we'd have that same voltage. Let's take a look, see if we do. There we go, 71.8 volts DC across the anode and cathode of that hockey puck SCR. So what's going to happen, we have 0 volts across the light bulb, the full voltage across the SCR. When that SCR is turned on, we'll in essence have the full voltage, 70 volts DC across the light bulb, and 0 volts across the SCR. Let's try it. All right. The light bulb just turned on. That indicates to us that we have the 70 volts DC across that light bulb now and nearly 0 volts across that SCR because it's turned on, it's conducting. That SCR is acting like a light switch. Now watch this, when we remove the gate voltage, the SCR is still turned on. In order for us to turn that light bulb off, we have to remove the voltage so that there's no holding current across that SCR. Okay, let's increase the voltage. There we go. We can turn that down. So now we have the full voltage across the light bulb, and we'll have nearly 0 volts across the SCR. Now let's remove the holding current of that SCR. We'll turn the DC bus back on, and you can see that the SCR is turned off. We have 0 volts here, 70 volts there. Let's increase the gate voltage to fire that SCR. We have 70 volts here and near 0 volts there. Let's measure that. We're going to measure across the anode and cathode of our SCR. I don't know if you can see that meter, but I'll read it out to you. We have 890 millivolts DC across that SCR because it's turned on. It's conducting. Well, there you go. There you go. You don't need the heat sink assemblies to compress your hockey puck SCR. You just need a woodworking clamp. Yeah, that is so cool. I wasn't sure if it was going to work, but there you go. It works. All right, all. Have a good day. Enjoy the time with your families. Enjoy the time on this side of the dirt. That is so cool. Woodworking clamp. Who'd have thought? Oh, you gotta love this job. It's so cool. Nice. Okay, let's head to the hooch.